What if our solar system is encased in a vast, invisible shell, an enormous barrier no one has ever seen?
So why does the Oort cloud stay hidden? Its icy bodies are too dim, too scattered, and too far away for any telescope to spot. Instead, astronomers have detected its presence by decoding the strange journeys of long-period comets, travelers whose orbits can outlast entire civilizations.
But to unlock the Oort cloud's secrets, we first need to ask, where does our solar system really end? This mysterious domain is called the Oort cloud. Though we cannot see it directly, its traces might be everywhere. Many of the comets that suddenly blaze across our skies could be ancient messengers from this dark frontier, hurled inward after slumbering for millions of years. They seem to arrive from every direction, hinting at a vast, three-dimensional halo that circles everything we know. Picture venturing far beyond the frozen edge of Pluto into a realm so remote that not even the most powerful telescope has glimpsed it. Scientists believe that out there, a colossal sphere of ice may surround us, sheltering billions, perhaps even trillions, of hidden worlds. These frigid wanderers orbit the sun from such distances that their presence lingers only as a ghostly hint in our calculations. If we ignore this invisible shell, we risk missing clues to our cosmic origins and overlooking threats that may emerge from the darkness. The Oort cloud might reveal where comets are born, what dangers they bring, and just how vast our solar neighborhood truly is. A map that could be far larger and stranger than we ever dared imagine. To trace the boundaries of our solar system, we must look beyond the planets and venture into the unknown. What evidence led astronomers to suspect this hidden shell exists at all? Let us start by mapping our cosmic neighborhood, from the worlds we know to the farthest shadowy borders. To truly understand the Oort cloud, we first need a quick tour of the solar system's architecture. Imagine the asteroid belt, nestled between Mars and Jupiter. Here, millions of rocky fragments orbit the sun, forming a dense yet delicate band. This belt marks the boundary between the small rocky planets and the distant gas giants. Travel farther, and you reach the Kuiper Belt, lying well beyond Neptune. This region is not just an icy wasteland. It is a sprawling field of frozen remnants left over from the birth of our solar system. Many short-period comets originate here, nudged by planetary gravity into neat, repeatable loops that bring them close to the sun every few decades or centuries. But then comes a cosmic mystery. While some comets return on reliable schedules, others suddenly appear from deep space. These long-period comets do not follow the solar system's plane. They arrive from every direction, as if hurled in from a distant, invisible sphere. Oort proposed a bold theory of icy bodies surrounds the sun, far past the planets and belts. This sphere, the Oort cloud, would be the solar system's hidden frontier, a realm of frozen worlds untouched by direct observation. This puzzle captured the imagination of Dutch astronomer Jan Oort in the early 20th century. He noticed that the orbits of long-period comets are so vast they may take millions of years to complete a single trip around the sun. Their random arrival directions pointed to a source far beyond any known planetary belt. But what clues first suggested such a mysterious spherical shell was out there, waiting to be found? Without understanding the asteroid belt, the Kuiper Belt, and the wild paths of comets, we cannot grasp the scale or stakes of the Oort cloud. Our view of the solar system remains incomplete if we overlook these faraway, secret regions. To unravel the Oort cloud's secret, we must follow the evidence left behind by the comets themselves. Their strange orbits tell a story written in the darkness beyond Neptune. When comets streak in from every corner of the sky, what vast reservoir do they escape from? The answer may lie in one of astronomy's greatest enigmas, the Oort cloud. Unlike the short-period comets, which loop in predictable orbits and cling to the plane of the planets, long-period comets break all patterns. They arrive from seemingly random directions, hinting at a sprawling, three-dimensional swarm that envelops our solar system in a distant shell.
Without the Oort cloud hypothesis, we would ignore the true shape of our cosmic neighborhood and remain blind to the origins of these mysterious travelers. The Oort cloud transforms our sense of the solar system's boundaries and how comets, or even interstellar visitors, find their way to us. But if the Oort cloud exists, why has no telescope ever glimpsed it? The answer reveals the limits of both our technology and our imagination.
How did such a cloud form? The tale stretches back over 4.5 billion years to the solar system's turbulent youth. As planets grew and shifted, gravitational chaos reigned. Giant planets like Jupiter and Neptune hurled countless icy fragments outward. Some vanished into the void, but trillions settled into orbits so remote and scattered that they formed a spherical shell, the hypothesized Oort cloud. Occasionally, a passing star or the gentle pull of the Milky Way nudges one of these frozen relics, sending it plunging toward the inner solar system, blazing as a long-period comet. This cosmic mystery haunted astronomer Jan Oort, who scrutinized comet orbits from the past. He noticed something remarkable. The farthest points of these comet paths, their aphelion, tended to cluster at mind-boggling distances, roughly 50,000 astronomical units from the Sun. For context, Neptune orbits at about 30 astronomical units. The Kuiper Belt, home to Pluto and similar objects, stretches only to about 50 astronomical units. Even the scattered disk, a remote and sparse zone, barely reaches 1,000 astronomical units. Oort's findings pointed to a comet reservoir over 1,000 times farther than Neptune, an icy frontier verging on interstellar space. Why has no telescope ever glimpsed the Oort cloud, this theoretical shell that may wrap our solar system in ice and mystery? What keeps it hidden from even our most ambitious eyes? And how close are we, truly, to touching its frozen edge? Think about Voyager 2. Our bravest robotic scout. It has been racing away from Earth for more than 4 decades, yet after all that time, it has covered only a minuscule part of the journey to the Oort cloud's inner frontier. At its current velocity, it would need thousands of years just to reach the nearest outskirts of this distant realm. Astronomers analyze comet orbits, noting how their distant turning points group at astonishing ranges. Mathematical models, gravity, and statistics all point to the same conclusion. An immense, unseen cloud surrounds us, full of ancient ice. The argument is indirect, but powerful. If we cannot see it, why do scientists think it exists? The evidence is subtle, but compelling. Now and then, a long-period comet dives toward the sun from a random patch of sky, its trajectory betraying an origin far beyond Pluto. These icy messengers, some possibly from other stars, hint at a vast, wild realm beyond our sight. The Oort cloud keeps its secrets with distance and darkness. The icy rocks out there are so far apart and so dim that the most powerful telescopes can only peer into emptiness. Each one is as cold as deep space itself, almost invisible against the black. Every object is a solitary wanderer, separated by billions of kilometers from any neighbor. So what lessons can the Oort cloud offer, even as it hides from view? What could this cosmic border reveal about our place in the universe? If we insist on only believing what is directly visible, we risk shutting out whole domains of discovery. The Oort cloud's frontier teaches us that not all knowledge comes as light. Sometimes the universe speaks in hints and shadows. Ignoring those whispers would leave vast mysteries forever untouched. To answer that, we must look at what the Oort cloud represents, not just as a physical shell, but as a frontier of imagination and scientific humility. Its mysteries force us to confront the limits of our technology and our curiosity. Sometimes, the darkness reveals more than the light ever could.
Science is not just about what lies in plain sight, but about the truths we extract from what remains hidden. The most profound discoveries, whether the paths of distant comets or the invisible poles between planets, often emerge from the shadows between established facts. The story of the Oort Cloud echoes that bold tradition. We have never glimpsed its frozen peaks. Yet every strange comet, every odd orbit, and each simulation adds a new thread to the tapestry. These scraps of evidence, gathered across centuries, are breadcrumbs leading us to a vast, invisible frontier. Consider how we learned that Earth orbits the Sun. No one has ever witnessed our planet circling from afar. Instead, careful thinkers studied shifting patterns, subtle planetary motions, and fleeting shadows to piece together a new reality. Imagination, grounded by reason, unlocked a universe that had been hiding in plain sight. The Oort Cloud stands as proof of what patient curiosity can achieve. It shows that bold inference, seeing beyond the obvious, has always stretched the boundaries of human knowledge. Each new comet, each passing probe, helps us sketch the faint outline of a realm we may never witness directly. Still, the greatest mysteries refuse to yield easily. If the Oort Cloud exists, how could we ever hope to prove it? At its edge, the Oort Cloud marks a poetic border, the fading reach of the sun as it gives way to the galaxy's emptiness. It is the line between what we know and what we can only imagine. Here, mysteries beckon, questions just beyond our grasp, urging us to dream further. Will we finally reveal the Oort Cloud's secrets? Or will a new idea shatter our view of the solar system? If we ever abandon imagination and inference, we risk losing the very breakthroughs that define science. The next revolution may not arrive with a burst of light, but as a subtle pattern, a quiet signal from the dark. When we ignore the unseen, we close the door on understanding our universe and ourselves. Right now, the Oort Cloud stands as one of the greatest cosmic mysteries, a vast, invisible shell of icy worlds hiding at the edge of our imagination. Its presence is hinted at only by comets, ancient travelers with wild, unpredictable paths that swoop in from the dark, as if summoned from a realm we cannot see. So, will we ever capture direct proof of the Oort Cloud? Or are we close to a discovery that will overturn all our assumptions? Every question you ask, every doubt you share, helps drive science forward and brings us closer to answers that could reshape our place in the cosmos. The universe keeps its secrets only if we stop searching. Will you keep wondering? Keep questioning? Share your thoughts below, and let curiosity guide us toward the next astonishing breakthrough. Yet science thrives on what lies beyond direct sight. It is about piecing together clues, daring to ask why, and imagining what has never been seen. The Oort Cloud story pushes us to question what is real, to stretch the limits of our knowledge, and to accept that the universe may be stranger than we ever dreamed.